Good morning, and thank you for joining us for the third installment of Zico's Thought Leadership Forum. This time, we're going to be talking about the cost of poor burner maintenance. We are broadcasting to you today from Zico headquarters in beautiful but warm Broken Arrow, Oklahoma, as well as our office in Houston, Texas. Today, we've got some experts joining us who will explain what happens to process burner equipment when it's not maintained properly. And these would be things such as burner fouling, gas tip plugging, burner tile damage, and a few other items. We hope that with today's discussion and analysis, we can help provide you with some simple solutions and resources that will help your facility operate more safely and more efficiently in the future. And as always, all of these topics were chosen by you, our audience today, who are joining us from refineries, chemical plants, and other various industrial facilities around the world. We appreciate the many excellent questions that we had that were submitted today for today's session. And I will say that if this is your first time joining us for a Thought Leadership Forum, I'd like to say welcome and thank you for taking time out of your busy schedule. And our goal for the forum series is to answer your burning questions in a more casual and enjoyable environment than the traditional webinar. So feel free to sit back, relax, and enjoy the conversation. And so without further ado, let's first hear from our panelists today. And we'll start with Ryan Roberts. Ryan, can you introduce yourself and give us your background, please?
So good day to everybody who's attending the Thought Leadership Forum. My name's Ryan Roberts. I'm the Applications Engineering Manager for burner retrofits here at Zico. A little bit about my background. I am one of the few University of Oklahoma graduates here at Zico. I am a Sooner. Been with the company since August of 1995. Fortunate enough to work in our process burner group for 20 plus years, both on the project management side and in an applications engineering position as well. So most of my days now are involved with helping owner operators, just as everybody who's attending this, not only with the general burner questions, but maintenance burner questions and operations and how we can upgrade and help you solve combustion problems. So thank you.
All right. Well, thanks, Ryan. Since this is a public venue, I'm going to bite my tongue and resist the temptation to crack a few OU Sooner jokes. But I can just tell everybody Ryan is by far the smartest Sooner I've ever met. I will at least say that. Why don't we move on to Keith Wade? Keith, can you introduce yourself, please?
Sure. Thanks everybody for giving us your time today. We realize you got busy schedules. We're going to try to keep this at a practical level for most cases. I've been with Zico for 12 plus years now and working in a group called End User Support. Kind of a misnomer. If you look that up on the internet, it's going to show you an IT professional, and I'm probably the last guy you want helping with your IT needs. But yeah. I do have 20 plus years of combustion equipment supply, and then I've also got another 15 years of working inside of facilities and maintenance and operational roles. So my job and my group, we support your facility at the local level, helping you troubleshoot, helping you scope out projects, basically from idea of a project all the way through the life of the equipment. So thanks for your time today.
Thank you, Keith.
Oh, yeah, I forgot to say, I am a Red Raider. I'm sorry. So guns up, but I think that OSU has guns too, right?
Oklahoma State has guns as well. I think Keith, we can both agree that we'd rather play the Red Raiders and the Red Raiders play the Cowboys than either of us play the Sooners, I think.
Exactly.
Anyway, having said that, we probably ought to move on to Parker Emmel. Last but not least, Parker, can you introduce yourself, please?
Yeah, thank you. Thank you, everyone, for tuning in today. My name is Parker Emmel. I manage the process burner design department. My history here at Zico, I graduated from Oklahoma State University 12 years ago, and I started working in our testing and R&D facility, where I got to be a part of a lot of different applications, not only process burners, but other product lines, and got to be involved in R&D. And then since then, I've transitioned to managing the design team and supporting customers throughout the world, and excited to be a part of this forum.
Thanks, Parker. Parker's another smart guy, and not just because he went to Oklahoma State. Last but not least, I should have said this earlier, I'm Darton Zink. I am an OSU grad from many, many years ago. Been here at Zeco for 26 years, and I serve as our president and CEO, and hold the distinction of putting the first coat of paint on our first test furnace when I was a teenager, long time ago. So having said that, enough with the introductions. I will also make one special recognition, someone that's not on the screen. I'll introduce Clint Ellis. Clint is our technical event manager here at Zeco, and he works behind the scenes to help us navigate the content that we've put together for today's discussion, and he kind of helps keep us on track and wrangle us back in if we stray too far off topic. And so with that, Clint, why don't we kick things off with our first question. And the first question comes to us as follows. What is the normal maintenance duration for a process burner? And then a subset of that is, how is our maintenance frequency affected by higher hydrogen firing or 100% hydrogen firing? And are there any other maintenance considerations for this? So that's kind of a multi-part question. Ryan, why don't you take a stab at the first question, please?
Yeah, thank you. And so talking about normal maintenance duration, a lot of that's going to be a famous statement at Zeco, it depends. We should have a picture up on the screen for everybody to see. That may be a little bit of an extreme case with having, heavier hydrocarbons in your fuel. So one of the first questions we may ask you when you come talk to us about what's the frequency that I should be maintaining my gas tips, especially, it's going to depend on what your fuel gas composition is in your refinery fuel gas. If you do have a lot of, ethane, propanes, butanes, maybe some unsaturated hydrocarbons in the form of ethylene, propylenes, your maintenance duration is probably going to go up just because of soot formation. Combusting those fuels does, have a little bit of prompt NOx, but does form a little bit of soot. So we're definitely going to be talking to you about cleaning your tips on a much more frequent basis. We're also going to probably be talking to you a little bit about how much preheat you have for your fuel to make sure everything stays a gas. But generally speaking, you should be looking at your gas tips, once a day when your operations team is making the rounds. But it's not uncommon to be cleaning burner tips if you've got a relatively clean fuel gas every 6 or 8 months. And as your fuel gas composition gets heavier and heavier, or you have any liquid carryover or pipe scale rust from carbon steel piping, that can definitely decrease your frequency, where you're looking at that in weeks and maybe not in months. So I'll kind of open the floor to, I know Keith's got a lot of real world experience operating in the field. So
well, I can't challenge your first statement, though, that it depends, because it really does depend upon a bunch of variables. And so we will ask a lot of questions. But as a rule of thumb, I would tell you that a good burner maintenance program, you're able to get to all of your burners a couple of times a year in a good program. And so that's the PM type work, where you're going through them one at a time, looking at them and taking care of them. And hopefully what that does is that preempts you having a bunch of failures or plug tips that create process issues. The challenge you'll have in all the facilities is maintaining the folks in that group and getting a budget for it. Unfortunately, what happens is the burner cleaning crew is usually one of the first groups that gets sucked into capital whenever major turnaround work happens or a capital expansion job's going on. They pull the guys out of that burner crew and put their head count in somewhere else. So Ryan hit a lot of points. There's also, what type of furnace is it in? What's the severity of the furnace? Because, we see some process heaters that run 1300 F in the radiant section. And we see some ethylene applications that run 2200 F in the radiant section. So the environment you got this burner in is going to dictate some of the maintenance duration as well. And so it's not a simple answer. It's understanding, the fuel conditions that you have, and then the severity of the system that you're putting it in. But a good starting point would be to target trying to get all your burners looked at least twice a year.
Parker, anything else you care to add?
Yeah, on the same note, I echo what both Ryan and Keith said. The one other consideration is, the overall system. We talk about fuel gas quality. I've seen some customers where they've spent a considerable amount of money to make sure they strip out particulates and liquids in their fuel stream and have stainless steel piping downstream. They have to do a lot less maintenance regarding burner tip plugging than versus someone that maybe didn't invest that type of money in equipment. I've seen an installation where a contractor picked up a piece of pipe that had been laying out in the field for 15 years and put it into service. And there was a lot of other debris that then subsequently keeps continually plugging up burner tips. So,
well, even in the best fuel systems, if you've got carbon steel piping, there's going to be some moisture in the fuel systems. I mean, in purchased natural gas, there's water vapor. And so you're going to create flash rust inside of carbon steel piping. So that's just a given over time. And when you get in these facilities that are 25, 30 years old or older, there's a tremendous amount of flash rust and scale that are coming down the pipe. And so, yeah, going to a stainless system definitely alleviates a lot of that.
I just say for my part, an ounce of prevention is worth well more than a pound of cure. In this case, visual observation, cleaning and maintaining when the problem is small generally helps alleviate a lot of effort when you've plugged up a tip, then you burn up a tip and you've got to replace it, and that multiple time per year maintenance and visual observation is really important. And it's also something Keith and the folks in his group tend to help our customers out with as well. Why don't we move on to our next question, which is, what are some signs of pilots needing replacement? And got an example up on the screen of a pilot tip that absolutely needs replacement. But Parker, why don't you take this one?
Okay. Yeah, that's a great image to show there. The design of the pilot is to be very stable under a wide range of operating conditions because it's the ignition source for the burner. So if you have an unreliable pilot, it's a very big problem. So part of the pilot design is, the shield, which is the part that appears to be failed in this picture. It does operate at elevated temperature. That's to protect the pilot flame and to also be a good visual indicator that the pilot flame is stable. So, with this picture, it's obvious that the shield has over time degraded and is in need of replacement. If you see a pilot flame that is no longer burning down in the shield near the pilot tip, where those holes and slots are, then that can be an indicator of a problem maybe with the pilot tip itself. And then it can go into the electronics. A lot of pilots have monitoring devices, either a flame rod or a scanner to indicate pilot flame. And maybe as you see an increase in spurious trips and things like that, that may be an indicator of an underlying problem. That could even be, orifice plugging in the pilot or, the tip being failed.
Ryan or Keith, you guys have anything you want to add?
No,
I like this picture better.
Yeah, this is the picture.
I don't like talking about the failed ones, but this is what I like talking about.
This is the picture when we get asked this question. This is what you want the pilot to actually look like. Is Parker made a very good point that the tip and the shield are both in a heat affected zone, so they are components that are going to see elevated temperatures, and they are eventually going to fail because they have fire on them. But they're designed to have fire on them and designed for a long enough lifespan that you should get very good usable time frame out of them, but eventually they will need to be replaced. But this is always the picture that when we can see, components that are near failure or have failed. But this visual indicator right here is exactly what Parker was talking about. You do have some jets of flame that are coming out those holes in the slots so that your ignition system and your flame rods, can get proper rectification. But this, like I said, this gives you the point of, a nice stable pilot flame that's going to make your life in lighting off your burners much, much easier.
We showed a slide with the casting that had been run to failure mode where it cracked. What you'll see a lot of times is you'll see the flame, the brilliance of the picture with the pilot with the flame on, and how that tip is glowing really cherry red, and see the spokes real well. What you'll see over time as your operators are making their rounds is all of a sudden you'll lose the spokes out the bottom, or the tip will not be as brilliant hot. It'll start to go to something dull, and then eventually it'll get cool and turn where you can't even see the tip glowing. And so that's kind of the degradation process. You go from a pilot that looks like the photo to where you start to lose the spokes and you start to lose the brilliance of the shield around the pilot. And that's telling you that there's something generally restricting the flow of fuel or air to the pilot. And then therefore you're not getting as good of a heat release in the pilot as you'd like.
Yeah. And generally, if you go and look at the equipment in any frequency, you can see that degradation over time typically. And so other than, some special instances, maybe high hydrogen flashback or things like that, you can really see the pilot start to degrade before it becomes a dangerous piece of equipment where it's not in proper operating condition.
Good point. Yeah, good operator rounds, good recognition is going to point that out and turn it into a maintenance item instead of a shutdown item.
Yeah, and I'd say along those same lines, you want that pilot flame to be stable and robust. If you see it bouncing or dancing around, it's also a sign of trouble either at the pilot tip or even upstream of it in the mixer. Okay, let's move on to our next question, and which is what could be the possible reasons for flame quality changes related to poor maintenance and after performing maintenance. What are reasons for flame quality changes related to poor maintenance or changes that could take place after performing maintenance? Let's go back. Start with Keith this time.
All right. Well, typically what you're looking at, the photo on the right is showing some flame on the floor. And that's not a good thing. You want the flame above the tile. If I'd worked on these tips and put the burner back in service and saw this, first thing I would start to look at is, I got the tips oriented incorrectly. I'm shooting fuel somewhere where I don't want it. It's splashing and creating this little cloud down low. So one of the things that you're really going to pay attention to on when you put a burner back in service and it doesn't appear like it did before you took it out, and if there's something grossly wrong like this, is look at simple things. Look at height of the tips. Look at orientation of the holes on the tips. Hey, I've seen the occasion where there's two bins located in stores, and the maintenance guy goes and gets a tip that looks just like the one he took out, but it's not drilled correctly. It's drilled like the one for heater B instead of heater A. And so make sure that the proper tips are installed as well. So just because you're doing maintenance doesn't mean that you don't have issues when you bring one back up, but there's some things to look at when you do.
Right. Ryan, you want to add anything?
Yeah. So the important thing to remember here is one of the things we've preached in webinars. One of the easiest ways to look at this is consistency. You're looking for the burners should look the same. Whether it's the first burner you see or the last burner you see. That's another good indicator that if you, like I said, as Keith pointed out, that it's pretty easy to see that second burner's got some radically different flame patterns. So that's the area you need to be investigating. And the other point I'll just kind of want to throw out there to everybody that's owning and operating a burner, that no matter who your burner OEM is, you should have a burner general arrangement drawing that shows you the proper tip location and how to orient those tips properly with respect to the center line of your burner tile and how tall they should be off the floor of the furnace, et cetera. And so I'll always point this out, that if you have a Zeco burner or a Zeco piece of equipment and you don't know that you have that burner general arrangement drawing or that GA drawing, I tell you to reach out to the team here so we can get it in your hands. Because like anything else, being able to perform good maintenance means you're going to have successful operation. You're going to have operation that's not only safe, but is going to make you a lot of money. So if you can't put your hands on those drawings, please do come talk to us.
Yeah. Yeah, I agree with Ryan. Consistency is key. And, one thing I would recommend if you're in a facility that does allow pictures to be taken, when you first start up new equipment, it'd be good to really, under normal operating conditions, take pictures and video of what the flame quality looks like and have that as a reference point. Sometimes, as tips begin to plug, it's kind of it can be a gradual process, and it may be hard for, a new operator or whoever to really catch that. But if you have a good baseline to refer to, it's really easy to see, oh, this has really changed. Or if you purchased a burner test when you bought the equipment, you could go back and reference those pictures as well.
Yeah, all good points. And the only thing I'd tack on is not necessarily related to maintenance, but related to poor maintenance or not doing maintenance. Parker touched on it. As tips foul or plug, you're going to get flame shape issues. You're going to potentially get capacity issues. If you plug up half the tips on the burner and you make it up with pressure on those that are remaining, you're going to have flame quality problems, could have emissions problems, could have safety problems. Just want to kind of push the point that poor maintenance or even a poor maintenance interval can have a pretty serious consequence. But as Ryan mentioned, also taking care of the burners, maintaining them properly, can have also a very positive impact on overall performance, safety, and profitability.
Yeah. One other quick thing to mention is, if you've got questions or comments about if the burner flame looks good or not, tell you to reach out to the team here. But the one thing I forgot to mention that I should mention, strategic spare parts. It is, as Keith pointed out, not only having those spare parts so that when you do need to make a replacement, you can do it in the most cost-effective manner possible. So you can replace it right away. You're not having to expedite components to your site, but also making sure that everything is labeled properly so that tips that go in heater A make it into heater A and not into heater B.
Yeah. And I just to that point, if anybody on this call or your colleagues would like to have somebody take a look at your burners, your flame quality, whether they're our burners or somebody else's, that's something we're happy to help with.
Mm-hmm. Absolutely.
Yes, sir.
Move on to the next question, which is explain burner fouling and increased risk of flooding, as well as the effect on low pressure trips / curve. See, Ryan, you want to take that one?
Absolutely. So
great photo, by the way.
Yeah, this is a wonderful photo, and this is a very, very interesting question because 90% of what most people think of as burner fouling is the physical port actually plugging. But as the picture shows, this is a riser that's you've basically cut 40%, 50% of your effective open area in that riser because you've got all kinds of contaminants, sludge, carbon, whatever that's caked on the inside of this riser, and at least some of that's going to be inside your gas tip. So as a result, what we've done is we've cut the flow. So at a certain pressure with our capacity curve where it says, okay, at 20 pounds, I should be doing 5 million BTUs an hour. Right now at 20 pounds, I can guarantee you we may not be flowing everything. We need to do 20 million or the 5 million BTUs an hour. So that is, it's an interesting thing because also if you are partially plugged, you, as the question kind of says, with an increased risk of flooding, depending on which port actually gets plugged up, let's say you lose a little bit of your firing port or a little bit of your ignition port, you can start to see that flame blink on and off, and you can start putting some unburned hydrocarbons into the furnace. So depending on how bad that is, you can actually start to build up some amount of unburned hydrocarbon on the floor of the furnace, and how long that's going to take to actually cause a flooding incident where you start to see, high CO starts to affect the overall excess air rate. It's going to depend on how bad that is. But as you start to plug tips, if you've got your furnace on temperature control or some kind of process control that's looking at your outlet temperature, it's going to keep pushing harder on your control valve to open up and increase your pressure so that you can keep maintaining your throughput. So that can actually, lead you to overfiring the burner so that you don't have enough air for complete combustion. So yeah, you're essentially building one half of a fuel air explosive, and if you happen to give it more air, you can have a deflagration event. So there's a lot of different ways to kind of compound this problem, but once you start to see your pressure crop up from where it should be, and kind of back to Parker's point of knowing when your tips are in a very clean state what that fuel pressure actually is, so that historically you can look at it and go, wow, when we started at the end or the beginning of the run, it was 20 pounds, and now we're having to use same fuel gas composition, we're having to use 25 to 26 pounds to get that same throughput. That's a good indicator that you may have partially plugged tips. It would be good to look at your CO levels and look at your excess air levels to make sure that you aren't accidentally flooding the furnace. So,
yeah. And kind of to continue that, Ryan, if you have a tip that gets fully plugged and then ultimately, in a high temperature service falls off, say hypothetically, I've done this math before, but if you have a port that's 3/32 of an inch on one tip and it's a 1/2 inch riser, if the tip ultimately fell off and the area of the 1/2 inch riser is over 40 times the area that one port was before. So you can instantly go from, controlling your furnace to a rapid overfire where you have unburnt hydrocarbons and your substoichiometric.
Yeah, on the low side of this, the low pressure alarm side of it, I think the challenge you run into is if we've got the significant fouling like we saw in that riser and we go to low pressure, we're going to potentially be operating it below what we were able to demonstrate as a low fire stability point during testing. And so, you get in the same situation. You're now putting too little fuel in to get it to mix with the air, but it's going to find a way to mix with it at some point and find an ignition source.
Yeah, fouling, just to close this out, is a potential major problem, regardless of the firing rate and type of service.
Yes,
While
sir.
we move on to the next question, which does we kind of touched on this a little bit already, but next question is, how does fuel tip plugging affect the operating pressure of the burner? And I know Ryan and Parker kind of touched on that, but basically requires, in some cases, a lot more pressure to achieve the same firing rate, and with an associated set of consequences with it in terms of flame shape, stability, safety, and emissions. It has a very pronounced effect if you have any significant amount of plugging. With that, I'll move on to the next question, which is, what are the indications or indicators to replace a burner tile? Keith, you want to lead us off with this one?
Yeah, this is one of my pet peeves. Haven't been in the industry for quite a while. One of the things I see that gets overlooked and not included in the scope of outage work is burner tile. Not uncommon for people to be scheduling refractory work in a furnace because they've had something fall off the ceiling or off of a wall, but they don't always look at the burner tile. And the burner tile is critical because it's helping shape that flame more so than the gas jets are. If you think about the components of the combustion, it's, say 90 to 95% air and 5% to 10% fuel, depending upon the fuel. So the majority of the mass flow coming through that burner is air. And if I'm not metering that, shaping that well with a tile, I'm probably going to have flame issues and maybe stability issues and things associated with it. So I just challenge the listeners that when you go to look at your furnaces, make sure you take a good hard look at your burner tile. Now, I'm not going to be crazy enough to say if you got a crack in the tile that's just superficial that you need to do something with it. But if you've got things that are going to impact the ability to measure and mold that airflow, it needs to be addressed.
Yeah, this is a good picture that's up on the screen of, showing some, tile damage where you have some relatively major destruction. You're seeing a lot of surface cracks on those fins, and you're seeing material that's simply gone. So this is, as Keith pointed out, there's always going to be some surface cracks on any, thermal cycling, just, expansion, contraction. You are going to get some cracks, but this is a picture that's showing something that's, basically a major damage and has affected the structural integrity of the burner tile. So from, a burner's, got to meter the fuel and got to meter the air. And in this case, it's going to be difficult to meter that air once you've done damage to what the geometry of that tile looks like.
Yeah, one last practical comment. Whenever you get ready to go in a furnace, if you're doing any kind of tube work or any overhead work, a lot of this damage happens from things falling on it. So take the time and the effort and the money to build boxes to cover these things up if they're in good shape. And that way you can save yourself some headaches. But yeah, this one right here needs to be replaced.
I'd say one other comment is we design a number of our burners that utilize a ledge on the tile as a stabilization point. Other manufacturers do as well. So making sure that the tile is in good condition is not only important just for the operation and process performance, but it's also an important safety feature as well. So paying attention to tile. I agree with Keith's comment. If you've got a minor crack, that's pretty common and not a big deal. But if you see portions of the tile shape which have been altered due to damage or breakage or that sort of thing, that would be my recommendation as the point at which you need to repair or replace it. Okay, we'll move on to the next question, which is describe the importance of being able to operate your air registers. Are there newer and updated designs for registers and dampers? Sort of two-part question there. Parker, you want to take that one?
Sure. Yeah, so there's an image on the screen here that shows an air register design that's more common in the early history of burners, where you have an outer cylinder rotating on an inner cylinder. Those are very susceptible to corrosion and binding and things like that, and then ultimately failing where you can't really control the air. So a lot of times we move to the image that's showing right now, where you have individual linkages and bearings and ability to clean and adjust as needed to maintain the burner. And then we also have different designs where there are cast components that replace linkages so that the linkages can't be damaged or out of adjustment in the field, so you get more precise air control. It's really just critical to be able to control the air in any furnace, because I like to refer to the burner as treat it like a chemical reactor. Each individual burner is its own chemical reactor. You need to have control over both the fuel and the air going into that reaction. Otherwise, you lose control of it, and then it's susceptible to wherever the air and fuel is coming into the furnace. If the air is coming in through a side port instead of through the burner throat, the burner is not going to combust the fuel as it's designed originally. That has emissions impact, that has heat flux impact, flame quality issues, can cause convection section fouling or radiant tube fouling.
Yeah, I think that first photo that you showed of the old register, that looks like something my dad designed in the 1950s.
There's still some of them out there.
No, there's
Still a lot of them out there, yeah.
There's a lot of burners out there that look exactly like that, of that style of air control. And
this air register question is always a good one between operations and maintenance, because operations is getting challenged to try to control their heaters the most efficiently they can, and so one of the knobs they have is the air side, and if they can't move things, they can't efficiently operate that reaction like you were talking about, Parker. So the maintenance guys, your challenge here is that whenever you go to work on a burner, do what you can to make sure that the air side is functional. And if it's not functional, then it needs to go on your turnaround list and get replaced the next turnaround. And if it's a barrel in a barrel like the slide on the left shows, I challenge you to go look for an alternative to that for replacement register, because I think there's quite a few different ways to look at that and come up with a better solution.
Also add that one important feature when you talk about a furnace with multiple burners or lots of burners is the ability to control the air consistently from burner to burner, and the air register control and how easily and effectively you can make that airflow consistent from burner to burner. Okay, why don't we move on to the next question, which is there any provision for auto adjustment of air registers for controlling excess O2 and increasing burner efficiency and improving flame pattern?
Dart, and I've often thought you could tell the future, but man, you just did it, because you segued right into this one.
Yeah.
Well, Keith, lead us off here.
All right. Well, this picture shows an automatic air actuator, and the first one does here, and it's for each individual burner. And so there's the ability to position that air register from a remote location. Those can be done on a remote panel there in the field, or all the way back to DCS. Generally what happens is those are taken back into DCS, and so the O2 control of the furnace is adjusted through those automatic dampers. The next picture shows a jack shaft on a series of horizontally mounted, vertically fired stage fuel burners that are firing in an ethylene furnace. And we call that a jack shaft. And you can see the individual linkage rods dropping down off that jack shaft. So we're controlling 20 burners at a time with one actuator on that system. And both of those basically allow you to more efficiently control the O2 of your heater. Ryan, you going to talk a little bit about where we control O2 and where we control draft?
Sure. And on both of those, it's always one of the things we always try to say during Combustion Academy is everything that we're talking about right here, whether that's the picture where I've got individual, actuators, pneumatic actuators on the burner, or I've got that jack shaft system where I'm using one big actuator to control all the burners. That's the lever I'm going to pull to control excess air in the furnace. I'm going to use the stack damper to control and set my heater draft. And once that is set, I'm going to try not to touch that ever again. Because once I have the draft right, then all I need to do is to adjust the air registers or the air dampers on the burners themselves to get the excess air correct. And real quickly, just kind of the major difference between going with a jack shaft system versus individual pneumatic actuators, it's going to depend on if you've got a vertical cylindrical furnace, a jack shaft is going to be a challenge, whereas individual actuators make a lot more sense. Whereas if you're in a cabin style furnace and burners are in a row or in a line for the installation, that makes it a little bit smarter choice to use that jack shaft system. So, but it's both of those, and especially if you've got position transmitter feedback on those actuators, it's pretty easy for the burner management system and the DCS to get good feedback that I told the system to open up to 57% open, and the position transmitter can feed that back to you and tell you, yes, I am at that 57% open. So that's going to give better visibility to your operations staff.
It's a remarkably correct and practical statement coming from a Sooner. Move on to the, sorry, I had to take my shot.
It's okay. I promise not to ever chant SEC on this. How about that?
Oh, that hurts, Ryan. That's,
Yeah.
all right. Truce. Move on to the next question, which is, what is the minimum acceptable excess air level for a furnace? And we'll go to Parker.
That's a good question. I think you can look at it from two perspectives. From a burner perspective, in a very controlled environment, you can control excess air levels down below 10% excess air. As I mentioned in an earlier question, looking at a burner from a chemical reactor standpoint, it's a requirement of the whole system to really be able to control excess air very low. So if you have a furnace that has a lot of opportunity for leakage, where you have, site ports that are open or a lot of tube seals that have degraded, that's going to really limit the overall system on how low you can go on excess air. And I have seen personally in the field very large furnaces where they're sealed up and they had radiant section O2 monitoring where they could control the 10% excess air or below. Actually saw one go below 10% excess air to prove that they could operate at 10% on a normal basis. So really depends on the overall system.
Okay. Ryan or Keith, anything you want to add?
I was just going to say, 10% excess air is equal to about 2% excess O2. And kind of round numbers for us guys that deal in O2s instead of excess air. But yeah, your answer to question is exactly right. It depends upon the process as well. What kind of process variability does the process have? If I've got a process that changes on me 5 or 10 or 15% on the process flow, and I'm trying to control the coil outlet temperature, it's hard for me to run lower excess O2s because whenever they do ramp back in, if I'm not careful, I overfire and get to a substoke situation. So the process side affects the equation as well as the reaction side. I've seen some fairly large olefins furnaces run down in the 1% excess O2 or maybe even a little bit less, but that's a pretty steady process. It's a fairly well maintained box. And so, there's several things that go into that, but, I'd say that as far as an industry norm, what we normally see is people targeting 2.5%, 3% on a process heater, trying to get that on a day-to-day basis. And if they understand that they do have a leaky firebox like you were speaking, then they're going to elevate that to 5 or 6% so they get some margin there.
Yeah, that's correct. The tighter the box and the operating envelope, the greater the opportunity you have to go lower. Sure. Okay, let's move on to the next question, which is the question is higher hydrogen fuel cases. With higher hydrogen fuel cases on the rise, what are the challenges for maintaining a radiant wall burner? Brian, you want to take that one?
Sure. And so right now it's pretty routine to see somewhere between 50 to 70% hydrogen by volume in your fuel gas that's going to the radiant wall burner. And since it is a premix design and hydrogen wants to burn readily, you've got to really do as you start to see it increase above 70%. We've had some pretty good successes at 90 and 95% in the test facility here at Zeeco. But you have to the biggest challenge is making sure that your primary air doors are set properly so that you have a proper mixture, kind of as Parker talked about with this being a chemical reactor, making sure you have the correct amount of volumetric flow rate of premix air to your fuel so that you're actually burning at the tip instead of flashing back inside the mixer assembly. The picture we've got here does have see a wide variety of what those heat patterns on the wall look like. So you have some of them where you see the actual radial pattern where it looks like a donut, and in several cases you see only on the upper half, the lower half, and the one in the foreground you can see that tip's been damaged, whether that's coke formation or something's fallen on it, but you've really affected how much your fuel and your air can mix, and that becomes a challenge even when you have a fuel gas that's low in hydrogen, and that becomes much more difficult to maintain once you start to see your hydrogen levels increase. The second picture that they've brought up is something that's got a little bit better distribution. You're seeing a little bit better heat distribution from a radial heat pattern, but there are a few that when you look down the wall, you can definitely see that there's, that third burner looks like it's definitely got a much bigger pattern there. So it makes me wonder if there's been some damage to that particular burner tip that you're seeing a little more heat release. And things like that, when you're talking about very high hydrogen levels, can be a very big challenge. So,
Parker or Keith, anything you want to add?
Yeah, I think Ryan touched on a lot of good points. The as you go to higher hydrogen, the flame propagation speed is much faster. The flammability limits are much wider, and so the image that's shown on the left, where you can see some tip plugging, whether that's from liquid carryover from another fuel or some other debris. Any little place that forms a low pressure area in the tip and causes the tip to be at elevated temperature, when you go to high hydrogen, that greatly increases the probability of flashback. And so I think you have to be a little bit more on top of your maintenance program as you go to higher hydrogen with radiant wall burners.
Correct. Yeah, I mean, the takeaways for me, just to summarize, your maintenance program has to be more robust on a high hydrogen firing application, and also your operations in terms of adjusting the air doors and operating the burners within their defined performance envelope becomes more critical, or you end up with a flashback problem, or you can.
Yeah, I think industry experience is going to show, just echo exactly what you guys just said, that the higher hydrogen content we run in radiant wall burners, the higher the maintenance budgets have to be. It's just it's a tough animal, because like Parker said, one speck of dust getting in a slot, or one speck of rust getting in a slot and slowing the gas flow down, that hydrogen flame is going to attach there. As soon as it attaches, the metal's going to get hot, and it's going to just continue to propagate back up the venturi. And if you leave it long enough, it'll totally burn the venturi tip off. And so I think that the higher hydrogen you go in your fuel, you need to make sure you're communicating that with whoever your burner vendor is, number one, so they understand that and can try to develop the proper burner for you. Because there's a tremendous amount of work that goes into the momentum coming out of a gas tip in a higher hydrogen case. We're trying to make sure we don't have low pressure zones that are going to cause that flame to want to stabilize there. So make sure the burner guy knows what you're doing. And then number two, your maintenance program, like Darton said, is going to have to stay on top of it. It's going to be a rotating schedule where you're basically going to have burners coming in and out all the time.
To give you a quote from my dad's IndyCar racing days, the closer you run to the wall, the more careful you have to be. And draw a slight parallel with high hydrogen firing in a radiant wall burner. Okay, we'll move on to the next question, which is, it's, again, related to this. We can just touch on it. What's the relationship between flashback and the level of hydrogen content in a radiant wall burner? Or what's the relationship between hydrogen content and radiant wall burner and flashback? And I think we've kind of talked about that. The answer's pretty simple. The higher hydrogen content, the higher risk flashback in a radiant wall burner. We've got a photograph there that kind of gives you an indication what the symptoms of that look like.
A picture that is kind of awesome and terrifying at the same time. So,
yeah. I think one quick thing we didn't touch on with this question and the previous is, the higher hydrogen that you go, the more fuel pressure is required. A radiant wall burner, since it uses the fuel momentum to inspirate air, many times there's a startup case on natural gas or maybe a heavier fuel. That pressure range for the burner as you add hydrogen gets wider and wider and wider. And so that fuel pressure limitation can be a critical design point as well.
Yeah, I think a challenge that the customer has is when you're looking at that, you need to really understand how many furnaces am I going to try to bring on nat gas or some other fuel other than your normal higher hydrogen fuel. And so there's some compromises maybe that have to be made there. So I'm going to bring up 3 or 4 furnaces only, and I'll only bring those up to 75% of full capacity until I start making tail gas and putting it back into my fuel system and getting the hydrogen content up. We often get, hey, I got to be able to run every furnace on natural gas all the way up to full capacity. And that's just not realistic when you start talking about how the plants are run.
So along those lines, we have a question that is kind of dovetails on that, which are what are the maintenance considerations when there are large fuel gas composition ranges within burners? Parker, you want to take that one?
Sure. So one of the big things, kind of what we talked about earlier, is the wider range of fuel. So if you go from high hydrogen or a very large inert blend to a very heavy fuel, there's a very large pressure difference. And so, you're more likely to form soot or coke or things like that on the heavier fuel if you have a wider range. The other thing that can be another factor that we talked about earlier is liquid carryover. If the system is designed for normal operation on a higher pressure fuel, and then you come in with a very heavy hydrocarbon fuel that is not properly heated, you can have quite a bit of liquid carryover that can ultimately plug tips. So it's just challenging because, the burner has a fixed orifice. It's not like it's, some variable orifice where we can adjust to maintain pressure in a more desired realm for all fuels. We're kind of limited in most applications to all of the tips are firing for all cases, and so that pressure range can be quite large.
Right. Runner, Keith, anything you want to add?
About the only thing I would add is just having talked to some of our owners and operators about this, when you start to see that large pressure swing, is from a design standpoint, communicating to us that, those heavier fuels that Parker's talked about, knowing how often those you're actually going to have to operate those. Are they an emergency fuel? Because that's going to have some bearing on how we design our burners. And so that gives us an opportunity as burner designers kind of to steer that conversation and make an owner operator aware. These are some of the trade-offs that may have to occur, that, as Keith pointed out, that you may only be able to get to 75% on a natural gas fuel or on a heavier hydrocarbon. So that the sooner we can start that conversation, I think the better off we can be on making sure everybody's expectations are met. And that if you've got a fuel that you're running 90 to 95% of the time, our focus is on optimizing the burner performance to run very well there. And then when you are operating on those other cases, making sure you're bumping up your inspection frequencies and your maintenance frequencies to make sure that you're being proactive and not damaging any equipment. And Keith,
I think the
good follow up on that.
Yeah, go ahead, Keith.
I was just going to say that, the first picture we showed today had that cloud of carbon built up on that primary tip. That's a great one that shows you that you had some heavier hydrocarbons that didn't get mixed with air well, and so it turned into carbon. And so I think the challenges for maintenance are going to be the wider the range of fuels that you run, you're going to probably have a more intense maintenance program than you do if you're on a steady fuel that's pretty consistent.
Yeah, I think the better the communication is with the burner engineering team. The more we know about what fuels are going to be run 80% of the time or 90% of the time, the better job we can do to make sure that the burners not only perform well, but perform well from a maintenance standpoint.
Yeah,
well.
it's a balance of compromise and optimization is what it's a balance of.
Good, well said. Come up with our next question, which is what is the cost of poor burner maintenance? And that is a great question. I would say my view of that starts with it depends. But from my perspective, at its extreme, the cost of poor burner maintenance is safety. At a minimum, poor burner maintenance means you're not going to be operating as efficiently or making as much money with that furnace, or it's just going to be more troublesome down the road. Parker, any comments you have on that question?
Yeah, I mean, that's a great point. Ultimately, safety is very critical, and it's, all maintenance for the most part can prevent those dangerous situations. And it's much better from not only for us and you if you come to us early and we can help you do things in advance. Like having tips ready on site where it's not an emergency situation. We can partner with you and be ready for when those conditions arise. We also have teams of people that can go help with identifying these problems and service the equipment as well for you if it's not something that you feel comfortable doing. We want to partner with our customers and make them operate their equipment as best as they possibly can, so everyone's safe and makes the most money and is in emissions compliance.
I think Dart mentioned it earlier that at Zeco we feel like we're uniquely qualified to help with other people's equipment as well. We've got a lot of experience internally with folks that have worked at other OEMs, and so if you have other OEM equipment, don't let that discourage you from coming to us for help. We will look at your equipment with you. We'll make recommendations on it. And ultimately, if you get to the point where you're having trouble receiving equipment or getting any kind of response from any other of the OEMs, we'd love the opportunity to come in and help with those situations. And we're doing that not out of arrogance. We're doing that out of confidence in our knowledge and our abilities and our understanding of the combustion process. And so, it's completely different than it would be dealing with somebody that's not in the business, hadn't been in the business for years. Back to the cost of poor burner maintenance, I think every site has to evaluate that for themselves. What your costs for fuel are, what your costs of your products are. And so, the impact it's going to have to you ultimately is either safety or production. And so if you don't do good maintenance, every one of you has to figure out what your own risk management threshold is for those items.
Yeah, and just quickly to talk about some of those costs from a component standpoint, one of the things, since I do spend a lot of time looking and evaluating other OEMs' pieces of equipment, I'd kind of like to echo what Keith said, that if you're not getting service or support from another OEM, again, I tell you to reach out to us, because one of the things I will always like to point out that, especially when you're talking about burner maintenance and burner cleaning, relatively speaking, you're talking about something that is smaller in cost than other portions of your equipment that may need to be maintained. And you can, gas tips may be a few $100 to a few $1,000 that can definitely, in a best case scenario for you from a safety perspective, catching it early can prevent, multi-million-dollar per hour, downtimes in your facility by doing some very simple maintenance. And as everybody's pointed out, it's a small amount of capital to help make sure that you don't ever have really any safety excursions where you've got to explain to somebody why we've had significant damage to not only personnel but to equipment. And it's, again, kind of lastly, it's always good, having some of those strategic spares, whether it's for Zeeco's equipment or other OEMs pieces of equipment, just because my personal experience is always, you generally don't find out that the tip is gone bad and you need to replace it till it's 2:00 in the morning on Friday. And having that ability to help fix that problem in a timely fashion is going to be much more cost effective on you than waiting another 5 or 6 hours until companies open up and can actually service that request.
Oh, we don't sell that short, Ryan. We like those Friday fire drills. We like them.
We absolutely love them. They are wonderful opportunities. Happy to help, but ultimately, if you are responsible for your maintenance budgets at your facility, that's something to think about, because that's a good talking point with your management. Is we can, a little bit of forethought will help us avoid some of those 7-figure problems. We love to help you with those 7-figure problems, but
so Ryan, I'm gonna say it differently and just summarize it. That we do a lot of emergency work where we love doing it. We like helping customers, but it's a whole lot lower stress for us and for the customer
and for them.
when it's planned and happens on a regular maintenance interval.
Yes, sir.
And,
yeah.
And I see I'm getting a message now. Clint Ellis, who's managing our time here, is kind of giving me the hook that we need to wrap up. But we'd come back to it just to reinforce one specific point Keith made, which is for those that are operating facilities, we're here for you. We do about as much service work on equipment that was supplied by somebody else originally than we do on our own stuff. That's what we do all day, every day, and are happy to help. We want to be a resource and to make sure that we're not only selling equipment and hardware, but that we're helping our customers operate better and in a more safe and efficient manner. And that ultimately, that's what drives a good portion of our satisfaction with being in this business that's otherwise quite hard. Well, so thank you, Clint, for the signal to wrap up and that we're out of time. And I apologize that we didn't have time to address everybody's questions today. For all of you that did submit questions, our team will be reaching out and responding to you individually. And we hope that the discussion today was helpful and that it helps everybody run more efficiently, safer, mitigate issues that you might be experiencing in the field. And I would encourage everybody that if you have additional questions or comments or feedback for Zeeco, please fill out the form that is on this webpage, and that we'd invite you to submit any topics that you'd like our experts to discuss in the future or for our future editions of our Thought Leadership Forum. And lately, we're receiving a lot of questions related to hydrogen-fired burners. We're seeing that at an increasing rate. And while we mentioned hydrogen a couple of times in the conversation today, we plan to dedicate an entire Thought Leadership Forum to the topic of hydrogen and hydrogen firing in the near future. And I'll close just by saying thanks again for joining us today for our latest episode in this series. We hope you enjoyed the event as much as we enjoyed delivering it to you. And please follow us on social media to stay up to date on our Thought Leadership Forum series and other upcoming events that we produce here at Zeeco and that we have planned for you. And we look forward to hopefully seeing everybody in person, hopefully very soon. So appreciate everybody being here. And on behalf of the team, thank you very much.